Thank you very much for joining this class. So today we're going to be discussing on the module Introduction to Cryptography and Network Security. So maybe just to start, we just want to start by defining what is cryptography. So cryptography, the term cryptography is derived from two words. The other one is Greek, which is kryptos, and the other one graphene. So kryptos simply means hidden, and graphene simply means writing. So cryptography is hidden writing. So in cryptography we have what we call a plain text. So a plain text goes through the process of encryption, then we get a ciphertext. So when we have a ciphertext now, we're basically saying the message or the plain text is now in a version or in a form that is not easily understood or readable by the human eye or the human understanding. It has gone some form of manipulation, some form of conversion using algorithms, of course. Then when you want to view the plain text now, that ciphertext undergoes what we call decryption, which is the process of converting ciphertext into plain text. So we have a fundamental tenet of cryptography, which simply says if lots of smart people have failed to solve a problem, then it probably won't be solved soon. So in other words, we're basically saying cryptography emanated during the times of the World War I, whereby people were simply trying to send messages that were encoded such that the enemies would not be in a better position to actually intercept the messages. So that's when cryptography actually came into place. So we have what we call classical encryption techniques. So on classical encryption techniques, we have what we're going to be discussing with respect to symmetric cipher model, substitution techniques, transposition techniques, as well as steganography. So I'm going to start by describing what symmetric encryption is. So symmetric encryption, when we talk about symmetric encryption, we're simply talking about a private key or a single key or a conventional way of encrypting. So basically we are saying a sender and a recipient share a common key. And we're basically saying all classical encryption algorithms, they have what we call a private key. So we are basically saying symmetric encryption was the only type of encryption prior to the invention of the public keys. This was during the 1970s. So in this module there are some terminologies or some words that we're going to be encountering as we are going to be going on. So it is imperative for us to try and define some of these terms and try to understand what these terms mean. So we're going to be using the term plain text a lot, ciphertext, encryption, as well as decryption. So plain text is simply the message that you want to convey, or that you want to send, or that you want to transmit from a sender to a receiver, or from the sender to the recipient. Then we also have what we call ciphertext. Ciphertext is the outcome of is the result of when we actually encrypt our messages. When we encrypt our messages or we encrypt our plain text, we get what we call a ciphertext, or in unreadable format. Then we have what we call encryption. Encryption is simply the process of converting from plain text to ciphertext. Then decryption is the reverse or the inverse of encryption, where we are simply trying to restore the plain text from the ciphertext. Some of the terms that we're going to try and define is cryptography. So we're basically saying in cryptography, there are many schemes or ways that are used for encryption. And the study of those schemes that are used for encryption constitute the area or the study known as cryptography. So we also have what we call cryptanalysis. Cryptanalysis is the process of trying to break the code. That's what is known as cryptanalysis. Then we also have what we call cryptology. Cryptology is an area of cryptography and cryptanalysis. So, plain text is the original message. Then ciphertext is the coded message. Then we have what we call a cipher. A cipher is simply an algorithm for transforming plain text to ciphertext. Then we also have what we call a key. A key is basically the information that is used in the cipher if it's known only to the sender or to the receiver. Then to encrypt is simply to convert plain text to ciphertext. Then to decrypt or to decipher is recovering ciphertext from plain text. And we basically said cryptography is the study of encryption principles or methods. We also have what we call cryptanalysis or code breaking. These are methods of deciphering ciphertext without knowing the key. So now we're going to move on to the symmetric cipher model. So the symmetric cipher model, we're basically saying we have an input that is in plain text, so we can denote that as X. So we're basically saying that plain text undergoes some form of encryption using the various encryption algorithms that are present, the likes of AES or Advanced Encryption Standard or Data Encryption Standard, or this is a cipher, or the rail fence, or the plain fare, or the Wagner cipher, or the one-page cipher. Then this encryption algorithm, we're basically saying it makes use of a secret key that is usually shared by the sender and the recipient, which we're going to refer to as K. So once the plain text is manipulated through the use of an encryption algorithm and a key, we get what we call a ciphertext. So when we want to decipher now the ciphertext, we also make use of a decryption algorithm or a reverse of an encryption algorithm through the secret key that has been shared by the two recipients, which is the sender and the receiver. So now, the moment that ciphertext undergoes the process of decryption, that's where we say we obtain a plain text, which will be our output. So basically, the symmetric cipher model, it makes use of keys that has been shared and that are known by the sender and the recipient. Requirements. In order for the symmetric, or in order for the encryption process to actually be successful, there are basic requirements that have to be present. We're basically saying we also need So, in order for the encryption and decryption process, or the symmetric encryption or the symmetric cipher model to actually work, there are basic requirements that we require. For instance, you need to have a strong encryption algorithm, whereby we're basically saying an opponent who knows the algorithm and has access to one or more ciphertexts would be unable to decipher the ciphertext or figure out the key. So the first requirement is we need a strong encryption algorithm. Another requirement is security of the secret key or security of the private key. So we're basically saying who knows the key and the algorithm will be able to read all the communication using the key. So it is imperative for us to be in a better position to actually secure the secret key, or to ensure that the secret key is kept private and confidential. So we're basically saying two requirements for secure use of symmetric encryption is a strong encryption algorithm as well as a secret key that is known only to sender and the receiver. So the symmetric encryption scheme can be represented mathematically, whereby we are saying if we want to encrypt a particular message, we have to have a strong key, a strong encryption algorithm, as well as a secret key. So we have what we call model of symmetric crypto system. So we're basically saying we have a message source that undergoes some form of encryption through the use of an encryption algorithm. Then we have a key, so that is transmitted through a secure channel. Then it undergoes an encryption, a decryption algorithm. Then we have our destination, or where the message is intended to go. So we can also have a situation whereby we have an interception by the cryptanalyst. The cryptanalyst is someone who actually tries to break the code without the use of a key. So if that person is actually successful, the cryptanalyst can obtain the message as well as the key that has been used. So let's try and discuss with respect to security of symmetric encryption. So we're basically saying, in order for us to secure this symmetric encryption, it depends on the secrecy of the key. That's the first thing. If the key is not safe, then anyone can actually decipher our ciphertext. And also we're also saying we do not depend on the secrecy of the algorithm. The security of the symmetric encryption does not depend on the secrecy of the algorithm. And we're also saying we don't need to keep the algorithm secret. But what we need to keep only is the secret key, or we need to keep the key secret.